Looking at how this specific script handles that logic, well, it gives us this really fascinating window into algorithmic efficiency and, how Java handles memory under the hood. Yeah. So let's jump right into the mechanics. Before the program can do anything, it needs to get the data from you, right? So the script uses a standard scanner, bringing in the java.util scanner class. Right. And it uses nextLine to just grab the user's input from the console. So we get this whole raw riverbed of text, spaces and all. Yeah, the scanner is basically a microphone handed to the user. And, nextLine just ensures the program keeps listening until you take a breath. Until you hit enter. I like that analogy. So once it has the text, it hands that string off to the remove duplicates method. But before filtering anything, it does a quick cleaning path. Right. The very first thing that method does is run ftr.replaceAll, and it targets the spaces. It just strips out every single space instantly, right? Exactly. It uses a really simple regex pattern. But doing this first is actually super important for efficiency. Okay, wait, let's unpack this for a second. Right. Because if the ultimate goal is to filter out duplicates efficiently, doesn't running replace all up front mean we're iterating through the entire string in extra time? Yeah, it does. So why not just add a condition inside the main loop to ignore spaces as it goes? Well, you're hitting on a classic space-time trade-off here. Running replace all absolutely adds a preliminary pass. But by wiping the slate clean first, the core deduplication loop doesn't have to waste processing power checking if a character is a space on every single iteration. Oh, I see. Yeah, it streamlines the heavy lifting later, even if it adds that linear traversal right at the start. That makes a lot of sense. So now we have this solid block of characters, no spaces. The code then sets up an empty result string, which is like our collection pan, and we hit a for loop. Right, and it evaluates each character one by one using caret. But the real gatekeeper here is the condition result.indexOf. Right, checking if it equals -1. Exactly, this is the core engine of the script. IndexOf is searching the new result string that we're actively building. Okay, so if it returns -1, it means that specific character isn't in our pan yet. It's unique. You got it. So if I can visualize this, IndexOf isn't just a bouncer checking a VIP list at the door, right? Because it's a linear search. Yeah, it's a linear scan for the beginning. So the bouncer actually has to walk through the club, looking at every single person currently inside from the front door to the back, just to make sure you aren't already in there. That is a perfect way to put it, yes. And as the result string grows, that bouncer's walk gets longer and longer. Oh, wow. Yeah. So if the character is unique, the code adds it by just saying result equals result plus cheek. Right. But what if it's not unique? If the bouncer does find the character, say, the second in programming index of returns its position. The condition fails, and the loop just silently skips to the next letter. Okay, so the order of the letters stays intact. The word programming just becomes programming. Exactly. There's no alphabetical sorting. It strictly reflects the chronological first appearance of each unique character. That's super clean. But I want to circle back to that line. Result equals result plus cheech. From a performance standpoint, is this actually as lightweight as it looks? Not at all. And this is the hidden catch with Java. Wait, really? Yeah. Strings in Java are immutable. They cannot be changed once they're created. Oh, right. So when the code says result equals result plus check, it is not just tacking a letter onto the end of an existing string. So what's it doing? It's allocating an entirely new space in memory, copying the entire existing string over, and then adding the new character. Are you kidding me? So if I have 50 unique characters, it's creating 50 entirely separate string objects in memory behind the scenes. It is, yeah. I mean, it's a highly readable, elegant way to write the logic, but under the hood, it's generating a lot of discarded string objects for the garbage collector to clean up later. Wow. For a small script, it's virtually unnoticeable, but the mechanics are doing a lot more work than the simple syntax implies. Which brings us to a really interesting realization about scaling this whole thing, because this is a great miniature example of data sanitization, right? Taking messy input and distilling it down. Absolutely. It works beautifully for a handful of dirt. You get your unique